7. How are the elements of a 2D array stored in the memory? Row major order. In row major ordering, all of the rows of a 2D array are stored in memory in a contiguous manner. First, the first row of the array is entirely stored in memory, followed by the second row of the array, and so on until the final row. Column major order. In column major ordering, all of the columns of a 2D array are stored in memory in the same order. The first column of the array is entirely saved in memory, followed by the second row of the array, and so on until the last column of the array is wholly recorded in memory. 8. What is a linked list data structure? This is one of the most frequently asked data structure interview questions where the interviewer expects you to give a thorough answer. Try to explain as much as possible rather than finishing your answer in a sentence. It's a linear data structure or a sequence of data objects where elements are not stored in adjacent memory locations. The elements are linked using pointers to form a chain. Each element is a separate object, called a node. Each node has two items, a data field and a reference to the next node. The entry point in a linked list is called the head. Where the list is empty, the head is a null reference and the last node has a reference to null. A linked list is a dynamic data structure, where the number of nodes is not fixed, and the list has the ability to grow and shrink on demand. It is applied in cases where we deal with an unknown number of objects or don't know how many items are in the list. We need constant time insertions, deletions from the list, as in real-time computing where time predictability is critical. Random access to any elements is not needed. The algorithm requires a data structure where objects need to be stored irrespective of their physical address in memory. We need to insert items in the middle of the list as in a priority queue. Some implementations are stacks and queues, graphs, directory of names, dynamic memory allocation, and performing arithmetic operations on long integers. Become a data scientist with hands-on training. Data Scientist Master's Program Explore Program. 9. Are linked lists considered linear or nonlinear data structures? Linked lists are considered both linear and nonlinear data structures depending upon the application they are used for. When used for access strategies, it is considered as a linear data structure. When used for data storage, it is considered a nonlinear data structure. 10. What are the advantages of a linked list over an array? In which scenarios do we use linked list and when array? This is another frequently asked data structure interview questions. Advantages of a linked list over an array are: 1. Insertion and deletion. Insertion and deletion of nodes is an easier process, as we only update the address present in the next pointer of a node. It's expensive to do the same in an array as the room has to be created for the new elements and existing elements must be shifted. 2. Dynamic data structure. As a linked list is a dynamic data structure, there is no need to give an initial size as it can grow and shrink at runtime by allocating and deallocating memory. However, the size is limited in an array as the number of elements is statically stored in the main memory. 3. No wastage of memory. As the size of a linked list can increase or decrease depending on the demands of the program, and memory is allocated only when required, there is no memory wasted. In the case of an array, there is memory wastage. For instance, if we declare an array of size 10 and store only 5 elements in it, then the space for 5 elements is wasted. 4. Implementation. Data structures like stack and queues are more easily implemented using a linked list than an array. Some scenarios where we use linked list over array are when we know the upper limit on the number of elements in advance, when there are a large number of add or remove operations, when there are no large number of random access to elements, when we want to insert items in the middle of the list, such as when implementing a priority queue. Some scenarios in which we use array over the linked list are when we need to index or randomly access elements, when we know the number of elements in the array beforehand, so we can allocate the correct amount of memory, when we need speed when iterating through all the elements in the sequence. When memory is a concern, filled arrays use less memory than linked lists, as each element in the array is the data, but each linked list node requires the data as well as one or more pointers to the other elements in the linked list. In summary, we consider the requirements of space, time, and ease of implementation to decide whether to use a linked list or array. 11.